Hello and welcome back to this channel. This is Professor Rajesh Parapte, a book author of 25 plus engineering books. Dear students, this is the first session for the subject signals and systems. I will explain you the different types of signals. This topic is required, it is very much important because we will be using these words, these types of signals throughout this subject. So first of all, the definition of term signal. Signal is a physical quantity that varies with one or more variables. In our daily life also, we use this term signal anywhere. For example, we say traffic light signal, then satellite signal, TV signal, mobile signal. Then while performing practicals, we use this type of signals like sine wave signal, then triangular wave signal, square wave signal, and so on. So signal is a general word. Under signal, there are different types. First type is continuous or discrete signal. A continuous signal is also abbreviated as CT. It is also known as continuous time signal, or discrete time signal, which is abbreviated as DT, discrete time signal. Next is periodic or non-periodic signal. If signal is repeating, it is periodic, otherwise it is non-periodic. Next is even, it is also called as symmetric or odd, which is also known as antisymmetric or asymmetric signal. Next is fourth is energy or power signal, and last type is deterministic or random signal. We'll discuss each type in detail. The first type of signal is continuous or discrete signal. As I mentioned earlier, continuous signal is also abbreviated as CT, continuous time. Discrete signal is abbreviated as DT, discrete time signal. Now consider an example of a standard sine wave. We know that this is the diagram of sine wave. Ideally, it starts from origin and the signal repeats up to infinity. The mathematical notation is x of t. This is known as a continuous signal or CT signal, continuous time signal. I have written its definition. It is the signal which is defined and represented at any instant of time. It is also known as analog signal. It is defined as well as represented at any instant of time. So at any instant, some amplitude is present. It might be 0. And at other instants, it is again changing. So it is continuously changing with respect to time period. It is known as continuous time signal. It is also called analog signal. Next is the diagram for discrete signal. Now before that, the mathematical notation is x of t. This x, when I write x of t, we know that t represents the time period. We read it like this: x is function of time period. X represents amplitude of signal. So x is amplitude, t is the time period. Mathematically we read it like this: x is function of time period. That means amplitude is function of time period, or amplitude is changing with respect to time period. This x also represents the shape of signal. So the notation is x of t, x is amplitude, t is the time period. Now mathematical equation of this continuous time signal, for this sine wave, we know that it is represented like this: A sine omega t. A is maximum amplitude. Sine, why I have written sine? Because the nature of wave is sinusoidal. If it would have been a cosine wave, I would have written A cos omega t. Omega is angular frequency, which is 2 pi f. T is the time period. This is the mathematical formula for the sine wave signal which I have drawn. It is known as the CT signal or continuous time signal, which is function of time period. That means it is changing with respect to time period. It is also called analog signal. Next is the diagram for discrete signal. Make the thing simple. If the signal is in the form of pulses, it is known as a discrete signal. How to write a definition of this? We have discussed the definition of CT signal. Just make few changes. The original statement remains same. It is the signal which is defined and represented at, instead of any instant of time, we will have to write at certain instant of time. Look at this diagram. I have written on x-axis, I have written some variable n. This n is known as index. It represents a corresponding number. Whatever things I have drawn, each thing is called as a pulse. So n is index, which represents presence of pulse. value of n, which is value of index, is always an integer like 0, 1, 2, 3, 4 up to infinity. It cannot be a non-integer value. So it is the graph of x of n versus n. What is the change in the first diagram? In case of CT signal, on x-axis I have plotted t, that is time period. In case of DT signal, I have to plot n, which is representing an index, and draw the diagram in the form of pulses. So this pulse indicates presence of signal. For example, if this amplitude is 0, I have marked here 0. Suppose I will mark some instants like this. Suppose at this instant amplitude is 1 volt, at second instant amplitude is 2 volt, at third instant amplitude is again 1 volt, and so on. Again at this instant it becomes 0. So what I have done, at 0 I have marked the point of 0. At this value of time period, say it is 1 second as an example, then at 1 second amplitude is 1 volt, so I have drawn a pulse representing 1 volt. At say 2 seconds, this is the time instant representing 2 seconds. At 2 seconds amplitude is 2 volt. What I have done, I have marked a pulse of the amplitude of 2 volt. Then at, let us say this is 3 seconds, at 3 seconds again amplitude is 1 volt, I have marked a pulse. Likewise go on marking different pulses. Whatever signal you are getting, that is known as DT signal, that is discrete time signal. The speciality of this signal is, if you join all these pulses like this, again we are going to get the same signal, which is the original analog signal. So this is known as a discrete time signal or DT signal. Keep in mind, in case of t, I have used the notation n. What about mathematical expression? As I said, if you join these pulses, again you are going to get the original signal. Original signal is a sine wave. This is again a sine wave, but it is in the sampled form, which is known as a discrete form. Now, how to write the mathematical equation? Throughout the subject, there are two types of equations. One is continuous, another is discrete. You don't have to mug up the things. I will tell you simple trick. If you know the equation of continuous time signal, just replace t by n. For example, I have already discussed this equation of a sine wave, which is a sine omega t. If I want to write mathematical expression for discrete sine wave for this diagram, then how to do it? Keep a as it is, keep sine as it is, because it is again a sinusoidal signal, but it is in discrete form. Omega is again as it is, only in place of t I will have to write n. So x of n is a sine omega n. That's it. This is the mathematical expression for discrete time signal. So it is the signal which is present only at certain instant of time. These certain instants are known as discrete instants or discrete time. You can well define it as, it is the signal which is present at some discrete time instants, and that is the discrete time signal. Then the question arises whether this DT signal is a digital signal, a signal which is discrete in amplitude as well as time. I am repeating, a signal which is discrete in amplitude as well as time is known as a digital signal, whereas this x of t, continuous signal, is known as the analog signal. So these are the basic types. One is CT and another is DT signal. Related to this, or rather extension of this, is the next type, that is periodic or non-periodic signal. As the name itself indicates, periodic means the signal should repeat after some time period. For example, I have drawn this sine wave. As I mentioned earlier, this is the sine wave which is ideally till infinity like this. It goes on increasing till infinity. I will mark few readings. We know that this is 0 origin, this is pi, this is 2 pi. From 0 to pi there is a positive half cycle. From pi to 2 pi there is a negative half cycle. After 2 pi again the signal repeats like this. So this same portion is getting repeated till infinity. This is known as a periodic signal. Very simple. So if the signal repeats itself after certain time period, in this case this time period is 2 pi. So after 2 pi, in the present case the signal repeats itself, it is known as a periodic signal. Now after which value this signal repeats, it is getting repeated after the value 2 pi. So this value 2 pi is known as fundamental period. So in this case, the value of fundamental period is 2 pi, because after 2 pi signal repeats. Very simple. The value after which signal repeats is known as the fundamental period. Notation is capital T. So capital T is equals to 2 pi. Again, throughout this subject there are many notations, but you have to remember it logically. Make the thing simple. It is CT signal, that is continuous time signal, which is represented by x of t. Small t is the basic notation. In case of periodic signal, the period after which signal repeats is denoted by capital T. Since there is a small t, I am using notation capital T. So capital T is equals to 2 pi. What about units? This is actually value of time period, but it is in terms of pi, so unit is radians. If it would have been only 2, 3 like this, I would have written the unit seconds. Presently, it is 2 pi radians. Now, mathematically, any periodic signal can be represented like this. X of t is equals to x of t plus capital T. Very simple. After capital T, that means after 2 pi, value of capital T is 2 pi in this case, the signal repeats. So x of t is same as x of t plus capital T. Or after capital T, I mean after this value which is 2 pi, which represents capital T, same signal repeats. So mathematical equation is x of t is equals to x of t plus capital T. Now, this is the discrete signal which is obtained from the continuous signal. Just now I explained, if you join all these pulses, you will get the original signal back. So it is similar to the continuous signal, only nature is discrete, so it is known as a discrete time signal. Now, how to write mathematical expressions? Again, on the same lines, you will have to just make changes in the notation. For example, this is the equation x of t is equals to x of t plus capital T is the mathematical equation of periodic signal for CT, that is continuous time signal. If I want to write mathematical condition for DT signal, then making use of this same equation, I can write it like this: x of n is equals to x of n plus capital N. Very simple. In place of small t, I have used small n. In place of capital T, I have used notation capital N. So if this condition is satisfied, then discrete signal is periodic in nature. Now in this case, what I said, capital T is equals to 2 pi. That means after 2 pi, values repeat, signal repeats. In this case, I have written few numbers like 0, 1, 2, 3. You can well say after value 8, when n is equals to 8, you are getting 0 as like the original case. Again after 8, you are going to get the same diagram like this. So 8 is the value after which signal repeats. So fundamental period for discrete signal in this case is n is equals to 8. What about unit? In the earlier case, it was 2 pi. So we said unit is radians. In this case, n is equals to 8. What this number 8 indicates? It represents number of samples. We will refer it like this. This is 0th sample, first sample, second sample, likewise 8th sample. So after 8 values are repeating, so n is equals to 8. N is fundamental period, which is 8, and unit is samples. So it is repeating after 8 samples. So these are very important types. One is CT and DT, and next is periodic or non-periodic signal. The next type of signal is even or odd signal. I have drawn 4 diagrams, 2 for continuous signal and remaining 2 for discrete signals. Let us talk about this first diagram. Just now we discussed, when I write x of t, t represents time period, x represents amplitude. I have drawn one signal. Half part of this signal is at positive time period, remaining half portion is at negative time period. Suppose I will mark few notations. If I will say this part which is present on positive time period is A, whereas part of this signal present at negative time period is B. We can easily say the two parts A and B are equal, having same area, and they are symmetric about vertical axis. So when the signal is symmetric about, this is the vertical axis, when the signal is symmetric about vertical axis, it is known as symmetric signal or even signal. Another name of even signal is the symmetric signal. Now, how to write the mathematical equation? Again, you don't have to mug up the things. I will tell you simple tricks how to generate mathematical equation. Just now we discussed one concept. When we write x of t, t represents time period, X represents amplitude of signal. If I want to write mathematical expression for part A, just you have to think, for part A, amplitude is positive. See, any amplitude which is above this line, this is the horizontal line, this is the zero value, any amplitude which is above this line is positive. If amplitude would have been below this line, it would have been negative. So amplitude of part A is negative. Amplitude is denoted by X. Time period for part A, this is at RHS of time axis. So time period for part A is again positive. So mathematical expression for part A can be written as plus X of plus T. Why plus X? As I mentioned, amplitude is positive. So X represents amplitude. So it is plus X. Time period is also positive for part A. So it is plus T. Simply it is written as X of T. Now, part B, as we discussed, part A and part B are symmetric. They are same, having same area. For part B, amplitude is positive. Amplitude is the portion, it is the portion which is above this zero line, above this horizontal line. So amplitude is positive. So for amplitude, I will write plus X. But for part B, time period is negative because part B is at left hand side of this axis. So any time period which is at LHS of this line is negative time period. So since time period is negative, I will write minus T. So mathematical equation for part B is plus X of minus T, or simply X of minus T. Plus is immaterial, so it is X of minus T. That means we can well say like this: if the mathematical condition X of T is equals to X of minus T is satisfied, then the signal is said to be even signal. Very simple. How to write definition in terms of words? As I said, if the signal is symmetric about vertical axis, it is known as even signal. Mathematical formula is X of T is equals to X of minus T. Now second case, this diagram, this is the case for continuous signal. If you want to write the equation, mathematical equation for discrete signal, make the things simple. Replace T by N. This is the diagram for discrete even signal. Same, from this diagram I have drawn this diagram, same diagram in the form of pulses. So if I want to write mathematical equation for even, which is discrete signal, so for even discrete signal, it is X of N is equals to X of minus N. What I did, simply I changed variable T by N. That's it. Now second case, this is the diagram for odd signal. See, again I have drawn one diagram and I will divide it into two parts, say part A and part B. Theoretically we can say that part A and part B are having same area, but they are opposite to each other. That means part A and part B are anti-symmetric about vertical axis. In this case, both parts, part A and part B, are symmetric about vertical axis, whereas part A and part B are anti-symmetric about vertical axis. Such signal is known as anti-symmetric or odd signal. So it is anti-symmetric or odd signal. Now about the mathematical equation. Look at part A. For part A, time period is positive because this is zero. Time period of part A is at RHS side. So time period is positive. Amplitude is also positive. So for part A, mathematical equation is plus X of plus T. That means simply it is X of T. For part B, time period is negative because part B is at negative time axis. This is the negative time axis. It is at LHS, as well as amplitude is negative. It is below this horizontal line. So for part B, I can write mathematical equation as, since amplitude is negative, I will write minus X. Time period is also negative, I will write minus T. Now the things are pretty simple. If the mathematical condition, I will write it over here. If the mathematical condition X of T is equals to minus X of minus T, then the signal is said to be odd or anti-symmetric signal. This is the diagram for discrete signal, which I have drawn it from continuous time signal. Same logic, if I want to write mathematical expression for discrete odd signal, then it is X of N is equals to minus X of minus N. So this is the mathematical equation for discrete odd signal. The second last type of signal is energy or power signal. The definition of energy signal is if average normalized energy of a signal is non-zero and finite, then it is energy signal. Now, what's the meaning of this average normalized? Average means we have to take average of the values for certain time period. Normalized means taking magnitude of the signal, take mode of signal which is normalized. So, if you calculate energy and average energy, and if you take magnitude of that, if such value is non-zero, it should not be zero, and if it is finite, it should not be infinity, then it is known as energy signal. Everyone is aware energy is denoted by E and its unit is joules. Now you just have to remember only one definition. If I want to write definition of a power signal, just replace the word. What I am doing, see, if average normalized power of a signal is non-zero and finite, then it is a power signal. Very simple. So just replace the word energy by power, you will get the definition of power signal, and we know that power is denoted by P and its unit is watt. The last type of signal is deterministic or random signal. As the name indicates, deterministic means there should be some mathematical equation or lookup table. What's the lookup table? Lookup table is the truth table. So if the signal can be expressed by using any mathematical formula or truth table, then it is known as a deterministic signal. For example, sine wave, cosine wave, triangular wave, square wave, all the signals, whatever we are using in practical cases are deterministic signal because mathematical formula of such signals is available. Then if this is not the case, means if you cannot represent it mathematically or by using any truth table, it is known as a random signal. Just now I mentioned almost all signals whatever we are using are deterministic signals. Then what's the example of random signal which cannot be represented by mathematical formula or lookup table? A good example of random signal is a noise which cannot be predicted. So noise is an example of a random signal. So dear students, this is all about the types of signals. As I mentioned, all these types of signals are very, very important for the entire subject. So thank you. Thanks for watching this video.